Good morning, everyone. Today we're going to talk about bonding. Bonding is all about attraction, but it is really difficult to define because it has got three different types. We have ion bonding, covalent bonding, and finally we have metallic bonding. All of these three, they're really important, and also it's frequently coming out in the exam, so you really need to know all those three in terms of definition and dot and cross diagram, or at least one example. So I'm going to talk about ion bonding first. So ion bonding, there's a way to find out an ion bonding is you need to look at the periodic table to see whether you have metal or non-metal. If you have metal and non-metal in the compounds, you have ion bonds. And if you have anything else, then we're going to talk about the other two. The ion bond has got really long definition, but I'm going to point out the keywords that you need to write down to get full marks. So number one, it is called electrostatic attraction, because electrostatic attraction is present in between oppositely charged ions. Because they do have charges, we must have electrostatic forces. So I'm going to use an example of Na and Cl, because Na is in group 1, so it is likely to lose 1 electron, and chlorine has got 7 electrons, so it is likely to gain 1 electron to become stable. Both of Na and Cl need to have 8 electrons to become stable, so when I draw that dot and cross diagram, you see that the dot is coming from the Na and going into the Cl, because Na does not need 1 electron to be there in the outer shell. So it goes to Na plus, where you have the inner shell that became now outer shell. So it has 8 electrons now, so it is stable. And Cl receives the 1 electron from the Na to make 8. As you can see that you have dot, not the cross. So this shows that the electron came from the Na, not from the Cl itself. So it has got 7 more electrons, altogether 8, and please remember it has got charges in it to represent that electron has been lost in Na, and chlorine gains an electron. Good. Another last point I would like to talk about, I said gain and loss, so you must say gain and loss in the definition. So with this, you're going to get full marks in terms of definition and dot and cross diagram. Let's go to the second one. It is called covalent bonds, and the covalent bonds occur in between non-metal and non-metal. It is really easy to write down the definition compared to the ion bond, because you only need to say share a pair of electrons. Share, you're going to get 1 mark, and a pair of electrons, you're going to get another mark. So make sure that you write down all of it. I have an example of HCl. H has got 1 electron in the outer shell, and Cl has got 7 electrons. This hydrogen, it needs another electron to become stable, and unlike the other atom, hydrogen has got only 1 electron and electron shell, and it only needs to get 2 electrons to become stable. And if you go to the second shell and third shell, for other atoms, you need 8, but at the beginning, you only need 2. So that's why the hydrogen needs 1 electron, and chlorine also needs 1 electron. So they cannot lose and gain electron, because they lose it, then they are not going to have full outer electrons. So they must have 1 electron from each side to be shared in the middle. So both of these H and Cl is now stable within the covalent bonds. The last one, but not the least, the metallic bonds. It is present in metal only, and the definition of metallic bond is the attraction between fixed metal ions and delocalized electrons. Many people don't know what delocalized means. Delocalized means that it is freely moving. An example, I wrote down Na. So let's look at the diagram of Na. Has got the structure of it. Has got plus, 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 meaning that has got fixed metal ion. So that's Na plus. And you've got E minus everywhere moving around. So I labeled it as delocalized electrons, and that's freely moving. And you can draw more than 2 electrons if you want in the diagram. That's it. So please remember all these 3, those are all important. Thank you very much.